So what does the distributive property says? According to the distributive property, multiplying the sum of two or more addend. What does this mean? That let's say we have two numbers. We are just talking about two numbers. There could be more than two numbers also. So let's say we have any two number 2 and 3. And why I'm adding this, because according to the property we just have to find the sum of the two addends. So we have just added up two numbers. Okay, now what we are going to do, now we are going to multiply the sum of the addends over here by a number. We are going to multiply the sum of this addend by a number. Let's multiply this sum of addend by a number. Let's say we are going to multiply it with 2. Okay, let me read the definition again. That multiplying the sum of two or more addend by a number. So we are just multiplying the sum of two numbers with a number, right? Or we could say sum of two numbers or sum of two addends with a number. That's what we are doing. We are just simply, we have two numbers. We have to find the sum of them and we to multiply them. Okay, so then further what does the definition says? That will give the same result as multiplying each addend individually by the number and then adding the product together. So what does it say is that there are two ways to solve this question. There are two ways to solve this question. What is the first way? The first way is that you solve inside the bracket first. Why you have to solve the inside the bracket first? Because of the BODMAS rule. So if you will go with the BODMAS rule, in that case you will simply add up 2 and 3 first. That will come out to be 5. And then you will multiply this 5 with 2, so you will get 10. This was according to the BODMAS rule. Now distributive property says that you can also solve the same question by multiplying the individual addend, right? By multiplying the individual addend by the number. I will highlight this point where it is written. It is written somewhere over here that will give the same result as multiplying each addend individually by a number. So what we are going to do, instead of solving it with the BODMAS rule, that is solving inside the bracket first, instead of that what we will do, we will just go with the distributive property. And what does the distributive property say is that you have to individually multiply these two addends. It means first you have to multiply this 2 and then you have to multiply this 3. Individually, one by one, you have to add them. Okay, so and we could also say the separately you have to add them, not one by one, but individually means separately you have to add them up. So in this case, let's multiply 2 with 2 first. So what will you get if you will multiply 2 with 2? You will get 4. Then what if I just multiply 2 with 3 then? Just a plus sign in between. Then a 6 and my answer will be 10. Now you can solve it in any way you know, you will get the same answer that we have got by the distributive property. Also, one more thing, that it is not always important that you multiply 2 with the 2 first. You can also multiply it with the 3. It's according to your wish. And this is what the property says. Okay, now if you see this thing, that first I multiplied this number with the addends individually, and then after that what did I do? After that I added as per asked according to the question, or we could say definition, sorry, that is then adding the product together. Let me just brief it up quick again. What we are going to do, we have two numbers for which we have to find the sum and then multiply it. That was the way we were following till now. But there is a very, very more easier way, or we could say there is a distributive property which says that you can just multiply this 2 with the first number and the second number individually, and you will get the same answer. This is what the distributive property say. Now if you want to see that where are we going to use this property, because we can simply add up this or we could simply find the answer for this thing by the BODMAS rule, then how do we use it? What is the purpose of it? What is the benefit of it? Let's talk about it. So we will understand all of this thing with the help of one question over here that says that evaluate 502 multiplied by 15 plus 2 multiplied by 502. Now we know one thing, that according to the BODMAS rule, if I go, then you have to multiply this number with this and you have to multiply this number with this, right? You just have to multiply 502 with 15 and 2 multiplied by 502. So technically, if I just write one thing over here, that is 502, and in the bracket if I write 15 plus 2, and if I open it up again using the distributive property, that will be 502 multiplied by 15 and then 502 multiplied by 2, or any order you want. So in that case, if I will multiply 502 with 15, I will get 7530. And if I will multiply 502 with 2, in that case I will get 1004. Okay, there is a one step missing in between. I missed it intentionally to tell you this thing, that over here if I'm going to solve it, I'm going to get the same answer, that is this, and over here I'm going to get 1004. And now, as I was talking about the missed step, let me write that also. So I'm just going to erase up everything over here and I'm going to redo this question to tell you that how this thing is similar to this thing. Okay, see, what I have done is I have 502, and I multiplied it with 15 and 2 individually. In that case, I am technically doing this, that is 502 multiply by 15, and as I was placing a plus sign in between, so a plus sign, and then 502 multiplied by 2 again, that is 502 multiplied by 2. If you will look at this equation and if you will look at the question which is being provided, this is exactly same. So you see that instead of just what we have done is we just had 502 and 15. Either you can solve it in this way as I have done according to the board mass rule, that is you have multiplied these two number first and then added up, or you could just go with the distributive property. This is exactly same thing, nothing but distributive property just tell us that you can separately or you can individually multiply the two number and then add, instead of just multiplying each one of them and that's because that's the same thing, that's not different. So you have to see the comparison, that we could also write this same thing, that is 502 multiplied by 15 plus 2 multiplied by 502. We can also write it in this way. Why? Because of the distributive property. What will be the answer in this case? When you are going to add them up, you will get the answer as 8534. So if someone just asks you that they just give you this question and they just ask you that, okay, solve out this question with the help of distributive property. They just give you this question and they ask you that solve out this question with the distributive property. In that case, what you are going to do? You're just going to find out that which number is common in them. You see, the number which is common in these two terms was 502. These are two terms. Why these are two terms and not four? Because see, terms is being made when they are being separated with the addition sign or a subtraction sign. When two numbers are in multiplication, obviously they are considered as one term, right? For example, if I write over here 2a plus 3b, then there are two terms only. Why not four? Because these two numbers are in multiplication with each other. This you can understand in the algebra more. But right now, so what we are saying, that 502 was common amongst them. So we can just take it common and multiply them individually with 15 and 2, and then also we will get the same answer, that will be 7530 and 1004, and further we can write it, it's going to be 8534. This is what the distributive property is. Let's do one more question quick to understand it further. Let's say I have a question which says 233 multiply by 5 plus 233. So I have something again over here. What is that? That this 233 is common among them. Now you will say that, man, there isn't two numbers right now. Okay, we know the properties of the multiplications now. So if I will write over here multiply by 1, will it change anything? No, it will not change anything, because we know that multiplying any number with 1 will give us the exact same answer. So even if there wasn't 1 over here, then I can imagine that yes, there is 1. Why? Because just multiplying anything. Okay. Now if I want to find the common number in them, as in the previous case the common was 502. In this case, if I want to find the common number, then what is it? It is 233. Why 233? Because these are present in both the terms. This is present in this term as well as in this term. It is present in both of the terms, so I can just take it common. Then what will I do? I will write the common term outside, that is 233, and the non-common one inside with 5 following with the plus sign and 1. And now I could solve it with the two ways, that is I could just add up 5 and 6 first and then multiply by 233, that will be the BODMAS rule. Or you could simply go with the distributive property, that is 233 multiply by 5 and 233 multiply by 1. Both are easy way, you can just go with any one of them. So when you are going to multiply 233 with 5, you will get 1165. Then when you are going to multiply 233 with 1, obviously you're going to get 233, because any number multiplied by 3 gives us that number back again. And then when you will add it up, you will get. And now you can do this question in any way you will get the same answer, but the only purpose was to tell you about the distributive property. Otherwise, you can do it in any way, you will get the same answer. This was the distributive property, which is very, very simple. It only tells you that if you have a number, or we could say if you have two numbers and you have a sum of them and you want to multiply it with another number, then in that case you can multiply them individually with the two numbers and then you can add them up. The answer will be same as that you are doing it with any other way. This was very simple, the distributive property.